So let's put these three ratios into some application. So in this case here, the angle in question is this one right here. And we're given the value of 10 on this side and 20 on this side. So we got to figure out what angle theta is here. So we have to determine what is the best ratio to use. So to determine the best ratio to use, we have to figure out what sides of the triangle we have. So theta is right here, and we have the opposite side. And we also have the hypotenuse. So the ratio that uses opposite and hypotenuse is the sine ratio. So sine theta is equal to the opposite divided by the hypotenuse. So, and basically we just got to fill in our values now. Side opposite is 10, hypotenuse is 20. That comes to 0.5. And if we put that in our calculator, theta is equal to second function sine 0.5. Entering that in the calculator, 10 divided by 20 equals 0.5. Second function sine equals, we got us 30-degree triangles. 30 degrees. All right, let's try another one out here. In this case, we've got 40-degree triangle. Side A is valued at 10, and we want to know what side C is. So we're still going to be using the sine ratio in this one because we have the angle, we've got the side opposite, and what it's asking for is to determine the hypotenuse. So if we start out with our formula, sine theta, it's equal to opposite divided by the hypotenuse. And I want to figure out what the hypotenuse is. I would just need to cross multiply. So the hypotenuse is equal to side opposite divided by sine of whatever angle we're at. Okay, so filling in values, side opposite is 10. We're going to divide it by the sine of 40 degrees. All right, so 10 divided by sine 40 equals 15.55. And that would be how long our hypotenuse is. 15.6. We'll round it to 6. Okay. Let's keep going here. We'll try another one. Okay, so on this one, we are given side B, which is 15, side C, which is 50, and we've got to determine what the angle is. So the angle in question is right here. We're given the side right close to it. So this is the adjacent side, and we are given the hypotenuse. So we are going to determine what angle is using adjacent and hypotenuse. And if we remember back, that would be the top. So cosine theta is equal to the side adjacent divided by our hypotenuse. Okay, well, just fill in some values. We've got the side adjacent, which is 15, and we're going to divide it by 50. And what's that going to come to? 0.3. All right, and if I want to figure out what angle theta is, it's second function cos 0.3. All right, so second function cos equals 72 degrees. Rough. Okay, on this one, we need to know what side B's length is. We're given the angle and we're given the hypotenuse. So once again, this is the side adjacent. This is the hypotenuse. And so we're going to be using the cosine ratio again. So cosine theta equals adjacent over our hypotenuse. And we got to know, we're trying to figure out what is the length of the adjacent side, side B. So we just got to do cross multiply again, hypotenuse times by hypotenuse, and adjacent side is equal to cosine of angle theta times the length of our hypotenuse. So in this case, cosine 35 times 70 is equal to cosine 35 times 70 equals 57.3. That's the length of side B. So side B equals 57.3. Alright, good stuff. Let's go one more. So in this case, we're given side B, which is 15. We are given side A, which is 10. And we got to determine the angle. So we got to determine the correct ratio. And we've got side opposite the angle. And we got the side adjacent. So the best option for this one is the tan ratio because it uses both those. So tan theta, the TOA, is opposite over adjacent. So if we just fill out our values here, we are going to have 10 divided by 15 so that's 0.6 repeating. I'm going to round to 0.67. And if I want to know what angle theta is, I'm going to go second function tan 0.67. Okay, so that would be second function tan times 0.67. That gives me an angle of 59 degrees, roughly, somewhere in there. Okay, let's do one more where they're given the angle and we've got to determine one of the sides here. So we need two values. So in this case, we're given side opposite the angle, given the angle, and we need to know side B. So once again, looking at this, we've got opposite, we need adjacent, and we have angle. So the best ratio again, tan theta equals opposite over adjacent, TOA. And I would need to find side B, which is my adjacent side. So I'm going to solve for that. So I have to swap the two. So adjacent is equal to side opposite divided by tan theta. So the opposite side is 30 and divided by tan of 25 degrees. So 30 divided by tan 25 equals 64, roughly. So about 64. And that's